All right, in this video, we're going to talk about suggested homework problems from 4.5. This has to do with what was the chain rule in differentiation. We're going to call it U substitution here with integration. Get up to the top of the assignment here and start with number 5 up here. So what we're looking at is this idea of compositions of functions when we differentiated them, that we had derivative with respect to x of f of g of x is equal to f prime of g of x times g prime of x. Well, what we're going to do now is we're going to say that if I have this thing that is f, lowercase f, which is a derivative of something, and g of x is, we're going to call it u, and g prime, we're going to call it u prime here. Antiderivative of all of that is going to be capital F of u plus c. So I hope you can see how that's related there. That is basically the same thing, but this is my function that I was differentiating to get that function. So that's really the f prime that's in here. G of x is replaced with u, and that's what we're going to do is this selection here to start off with of what's my g of x and what's my g prime of x, what's my u and what's my du. So in the integral 5x squared plus 1 squared is 10x dx, my u is going to have to be my inner function, 5x squared plus 1 du dx, or u prime, is 10x, so that makes du equal to 10x dx. And so that was number 5. Look now at number 7, that we have integral of tan squared x secant squared x dx. So the derivative of tangent is secant squared. So u is tangent x. Du is secant squared x dx, and this turns into a u to the second du. This was 5 times u to the, or this was u to the second du as well. Let's look at number 9. 9 now says it actually wants me to integrate 1 plus 6x raised to the 4th times 6 dx. So u is 1 plus 6x, du is 6 dx. So this is u to the 4th du, turns into u to the 5th over 5 plus c. That's 1/5 something to the 5th plus c, and the something was 1 plus 6x. Let's look at 11 now. 11 is root 25 minus x squared, negative 2x dx. U is 25 minus x squared. Du is a negative 2x dx. This is u to the 1/2 du. U to the 3/2 times 2/3 plus c is 2/3 25 minus x squared to the 3/2 plus c. Moving right along to number 13. 13 says integral of x cubed, x to the 4th plus 3 raised to the 2nd dx. u is my inner function of x to the fourth plus 3. Du is 4x cubed plus dx. So I need a 4 in here to make my du show up. So I'll balance it out with a 1/4, and that gives me 1/4 integral of u to the second du would be 1/4 u to the third over 3 plus c is 1/12 u to the third plus c, with u being x to the fourth plus 3. Let's move on to number 15. 15 says integral x squared 2x cubed minus 1 raised to the fourth dx. U is my inner function of 2x cubed minus 1. Du is 6x squared dx. So I'm going to fix this with a 6 and a 1/6. It's going to give me 1/6 integral of u to the fourth du is 1/6 u to the fifth over 5 plus c is 1/30 u to the fifth plus c. U is 2x cubed minus 1. Look now at number 17. 17 says integral of t root t squared plus 2. U is my inner function of, this is dt on the end. U is my inner function of t squared plus 2. Du is 2t dt. So I need 2 and 1/2 to balance it out. So this is 1/2 integral u to the 1/2 du. So 1/2 u to the 3/2 times 2/3 plus c. This will be 1/3 into the 3/2 plus c, and that's t squared plus 2. Let's look at number 19. Says integral 5x cube root 1 minus x squared dx. U is the inner function of 1 minus x squared. Du is a negative 2x dx. So that 5 is not helpful. I need cube root 1 minus x squared dx. And I need a negative 2 and divided by a negative 2. Give me a negative 5/2 on the outside, integral of u to the 1/3 du. That's negative 5/2 u to the 4/3 times 3/4 plus c. Negative 15 over 8, something to the 4/3 plus c, and something is 1 minus x squared. All right, let's look at 21. 21 says 7x over 1 minus x squared to the third dx. Inner function u is 1 minus x squared. Du is a negative 2x dx. 7 is not helpful. X dx. 1 minus x squared cubed. Negative 2 divided by negative 2. That's negative 7/2. Integral u to the negative third du is negative 7/2 u to the negative 2 over negative 2 plus c is going to be 7/4 And then something squared in the denominator, since it's an exponent of -2, plus c, and that something is 1 minus x squared. (23) integral x squared over 1 plus x cubed squared dx. U is 1 plus x cubed. Du is 3x squared dx. 1/3 integral u to the -2nd du. 1/3 u to the -1st over -1 plus c. -1 over 3 u plus c. -1 over 3 times 1 plus x cubed plus c. Okay. 25. Is integral x over root 1 minus x squared dx. U is 1 minus x squared. Du is a -2x dx. So there's -2, -1/2, -1/2 integral u to the -1/2 du. So -1/2 u to the 1/2 divided by 1/2 is times 2 plus c is a -1 square root 1 minus x squared. Look at 27. Integral 1 plus 1 over t cubed 1 over t squared dt. So my u is my inner function of 1 plus 1 over t, or 1 plus t to the -1st. Du is a -t to the -2nd dt, or -1 over t squared dt. So I need a negative and a negative. That makes a negative integral u to the 3rd du is a negative u to the 4th, 1/4, plus c is a -1/4 c, and this is 1 plus 1 over t. Look now at number 29. Because I want to use the chain rule, I'm going to let u be 2x, du be 2 dx. I'll fix this with times 2 and a times 1/2 to give me 1/2 u to the -1/2 du. It's 1/2 u to the 1/2 times 2 plus c is square root of 2x plus c. Let's move on to 31. 31 is a separable differential equation. dy dx is 4x plus 4x over square root of 16 minus x squared. So I'm going to move the dx over here. See, dy is 4x plus 4x over root 16 minus x squared dx. Then I want to integrate both sides, so y of x is equal to 4x squared over 2 plus, I have my u substitution here, for integral of root 16 minus x squared x. So u is 16 minus x squared, du is a negative 2x dx. So negative 2 divided by negative 2 get me y of x is 2x squared minus 2 integral u to the 1/2, u to the negative 1/2 du is y of x is 2x squared minus 2u to the 1/2 times 2 plus c is y of x is 2x squared minus 4 root 16 minus x squared plus c. Let's move on now to our next problem, which is 33. 33 says dy dx is equal to x plus 1 over x squared plus 2x minus 3 squared. Dy is equal to x squared plus 2x minus 3 squared x plus 1 dx by u is x squared plus 2x minus 3. Du is 2x plus 2 dx, or 2 times x plus 1 dx. So I have the x plus 1 dx. I need the 2. So 2 and 1/2 means y of x is equal to 1/2 integral u to the negative second du. Y of x is 1/2 u to the negative first over negative 1 plus c is a y of x is a negative 1 over 2u plus c, negative 1 over 2 times x squared plus 2x minus 3 plus c. Let's go on now to number 39. Those other topics with differential equations will be covered in differential equations. So integral pi sine pi x dx. Our u is now going to be inside of our trig function. So this is sine u du. What function do I differentiate to get sine? That's negative cosine. And this is pi x plus c. Let's look at 41. Cosine 6x dx u is 6x and du is 6 dx. So I need 6 and 1/6 to balance it out. So that's going to be 1/6 integral cosine of u du. It's 1/6 sine of u plus c is 1/6 sine of 6x plus c. Let's look at 43 now. 43 says integral 1 over theta squared cosine of 1 over theta d theta. My u is 1 over theta, or theta to the negative first. Du is a negative theta to the negative second. D theta, or negative 1 over theta squared d theta. So I need a negative 1 over theta squared d theta. This will be a negative integral cosine u du is a negative sine of u plus c. It's a negative sine of 1 over theta plus c. Move on now to number 45. 45 says integral sine 2x cosine 2x dx. There's several different ways to do this. I actually want to simplify this first. Do 2 and 1/2 to make this 1/2 integral of sine 4x dx, and then my u is going to be 4x. My du will be 4 dx. So this is 4 and 1/4 out here. We can have 1/8 times a negative cosine of 4x plus c. I didn't do my u substitution. 1/8 integral sine u du is 1/8 of negative cosine of u plus c is negative 1/8 cosine of u plus c is negative 1/8 cosine of 4x plus c. Now there's more than one way to do that problem. If I had looked at cosine as the exact derivative of sine, then I could have just done a 2 here and a 1/2 on the outside, and I would have gotten 1/4 sine squared of 2x plus c. So let me back up and do it that way. Get rid of this and this. So this is one of the right answers. I had said u is equal to sine of 2x. Du would be 2 cosine of 2x dx, and I would need a 2 and a 1/2, and this would be 1/2 of u du would be what that is, because u would be the entire sine function, would be 1/2 u squared over 2 plus c, be 1/4 u squared plus c, be 1/4 sine squared 2x plus c. And if I can write it as sine squared, I could also write it as cosine squared, because 1 minus cosine squared is sine squared. So this could also be 1/4 of 1 minus cosine squared 2x plus c, be 1/4 minus 1/4 of cosine squared 2x plus c. I'll call this C1, and that 1/4 gets absorbed into that constant over there and becomes a negative 1/4 cosine squared 2x plus constant of integration c. So there's three different right answers, or three different ways to express the right answer to this problem. That's one of the fun things about integration, is that you can get an answer that looks different than your neighbor because you thought of a different u substitution, and you can both be correct. So 47 is cosecant squared x cotangent cubed x dx. So the derivative of cotangent is negative cosecant squared. So u is cotangent x, du is a negative cosecant squared x dx. So I want a negative and a negative, and that makes a negative integral u to the negative third du. It's a negative u to the negative second over negative 2 plus c, a positive 1 over 2 u squared plus c. So 1 over 2 u is cotangent squared x plus c. So now at 49. 49 asks us to find a particular solution to solve for the constant c. So if f prime of x is equal to a negative sine of x over 2, and f of x contains the point 0.06, then f of x is integral of negative sine x over 2 dx. U is equal to x over 2, du is 1/2 dx. So 1/2 on the inside, 2 on the outside. F of x is equal to, this negative will come, can stay right there. So 2, and then cosine is the thing that I differentiate to get negative sine. So I'll call that 2 cosine of x over 2 plus c. And I guess I should have done u substitution there. 2 integral negative sine u du is 2 cosine u plus c is 2 cosine x over 2 plus c for my f of x. And then f of 0 is 2 cosine 0 over 2 plus c needs to be equal to 6. 2 times cosine of 0 plus c is equal to 6. 2 times 1 plus c is equal to 6. 2 plus c equals 6. c equals to 4. That's not my answer though, because I need to plug that in to my f of x. F of x is equal to 2 cosine x over 2 plus 4 is my final answer. Let's look now at 51. Says that f prime of x is equal to 2x 4x squared minus 10 quantity squared. we have the point 210. So f of x is equal to integral 2x 4x squared minus 10 quantity squared dx. U is 4x squared minus 10. Du is 8x dx. So I'm going to multiply by 4 on the inside and 1/4 on the outside. 2 times 4 will give me the 8 that I want. So f of x is going to give me 1/4 integral of u squared du, 51. So that's going to be 1/4 u to the third over 3 plus c. F of x is 1/12 u cubed plus c is 1/12 of, and u is 4x squared minus 10. So f of 2 is 1/12 of 4 times 2 squared minus 10 raised to the third plus c, and that needs to be equal to 10. So 1/12 of 4 times 4 is 16 minus 10 raised to the third plus c is equal to 10. 1/12 of 6 to the third plus c is 10. So 1/12 times 6 times 6 times 6 plus c is 10. 6 goes into 12 2 times, 2 goes into 6 3 times, 3 times 6 is 18, plus c is equal to 10, and c is a -8. If c is a -8, then f of x is equal to 1/12 of 4x squared minus 10 cubed minus 8. Now at number 53. I'm going to do these a little bit different than I did my u substitutions with the other ones. And the reason why is because I can't take the derivative of the unit function and get this piece that's on the outside because it's too high of a degree. So I'm instead going to make a substitution here where u is equal to x plus 6. I'm going to solve for x in terms of u. The x is equal to u minus 6. And then I want to find dx. So dx is du in this case. I'll make my substitutions. X is u minus 6. This is the square root of u, so u to the 1/2, and dx is du. So I'm going to distribute from the right here, integral of u to the 3/2 minus 6u to the 1/2 du is u to the 3/2 du minus 6 integral u to the 1/2 du is u to the 5/2 times 2/5 minus 6u to the 3/2, and this is times 2/3 plus c. This 3 will go into there 2 times. This is 2/5 of something to the 5/2 minus 2 times 2 is 4, something to the 3/2 plus c, and those somethings are x plus 6 and x plus 6. So 2/5 x plus 6 to the 5/2 minus 4x plus 6 to the 3/2 plus c. Let's look at 55 now. So my u is my inner function of 1 minus x. I'm going to solve that x is equal to 1 minus u. Dx is equal to a negative du. So we have integral of x squared times u to the 1/2 times a negative du when I substitute dx here. So let's expand here. 1 minus 2u plus u squared. I have my u to the 1/2. I have my negative can come out du. So negative u to the 1/2 du plus 2 equal u to the 3/2 du minus u to the 5/2 du. So this is negative u to the 3/2 times 2/3 plus 2u to the 5/2 times 2/5 minus, this is u to the 7/2 times 2/7 plus c. It's negative 2/3 of something to the 3/2. Something is 1 minus x plus 4/5 of something to the 5/2, and that again is 1 minus x minus 2/7 of something to the 7/2, which is 1 minus x. So let's see here. This is yep. So that's that. And let's move on. To what's the next one? Number 57. 57 says integral of x squared minus 1 over root 2x minus 1 dx. So u is 2x minus 1, and that makes u plus 1 equal to 2x, and x equal to 1/2 u plus 1/2, making dx equal to 1/2 du. So this is u to the 1/2. This is 1/2 du, and this is same thing as 1/2 u plus 1. So when I square that, that's 1/4 u plus 1 squared minus 1. And I will take the 1/4 out of this and the 1/2 out and make it 1/8 u plus 1 squared minus 4 over u to the 1/2 du. So this is 1/8 integral u squared plus 2u plus 1 minus 4 is minus 3 over u to the 1/2 du is 1/8 of integral u to the 3/2 du plus 2 integral u to the 1/2 du minus 3 integral u to the negative 1/2 du. So 1/8 on the outside, u to the 5/2 times 2/5 plus 2u to the 3/2 times 2/3 minus 3u to the 1/2 times 2 plus c is 1/8 of 2/5 u to the 5/2 plus 4/3 u to the 3/2 minus 6 u to the 1/2 plus c, and u was 2x minus 1. Just so I don't lose track of that. So let's pull a 15 out from here. 1/8 times 15 is going to be 3 times 2 is 6 u to the 5/2 plus 20 u to the 3/2 minus 15 times 6, that's 90 u to the 1/2 plus c. All those are even numbers, so pull a 2 out. It's 2, 8, 15 is 3u to the 5/2 plus 10u to the 3/2 minus 45u to the 1/2 plus c. 2 goes into 8 4 times. And this is 1/60. And then this is u to the 1/2 can come out. And this is 3 u to the 2nd plus 10u minus 45 plus c. So this is square root 1/60, square root of, so I didn't want to lose this, 2x minus 1 times 3 times 2x minus 1 squared plus 10 times 2x minus 1 minus 45. And I need to condense what's on the inside there to combine all my like terms and such. So this is 1/60 root 2x minus 1 times 3 times 4x squared minus 4x plus 1 plus 20x minus 10 minus 45 plus c is 1/60 root 2x minus 1 times 12x squared minus 12x plus 3 plus 20x minus 10 minus 45 plus c. 1/60 root 2x minus 1 times 12x squared. Negative 12 and 20 is 8x. And then negative 55 plus 3 is negative 52. Those all have a common factor of 4. I'm going to pull out, so 4/60 root 2x minus 1 is 3x squared plus 2x minus 13. And that's 1/15 root 2x minus 1 times 3x squared plus 2x minus 13 plus c. All right, let's look at number 59. Interval cosine cubed 2x sine 2x dx. U is cosine 2x. Du is a negative sine 2x times 2 dx. So we need a negative and a negative, and we need a 2 and a 1/2 to balance it out. So we have a negative 1/2 u to the third du. So that's a negative 1/2 u to the fourth over 4 plus c is a negative 1/8 u to the fourth plus c is a negative 1/8 cosine to the fourth of 2x plus c. Let's look at 69. And 69 asks us to integrate 0 to 7 x cube root x plus 1 dx. So I need to make a u substitution. U is x plus 1, x is u minus 1, dx is du. So this is going to go from u is going to go 0 plus 1 is 1, 7 plus 1 is 8, x is u minus 1 times u to the 1/3, and this is du. So this is 1 to 8, u to the 4/3 minus u to the 1/3 du is u to the 7/3 times 3/7 minus u to the 4/3 times 3/4. Evaluate that from 1 to 8. So this is 3/7. Cube root of 8 is 2. 2 to the 7th minus 3/4 of cube root of 8 is 2. 2 to the 4th. So this is minus, I'm going to evaluate a 1. 3/7 times, this will all be 1, minus 3/4, and that will all be 1. So this is 2 to the 4th times 3/7 times 2 to the 3rd minus 3/4 minus, this is over 28. This is 12 minus 21. This is 16 times 24 over 7 minus 3 over 4 plus 21 minus 12 over 28 is going to be 16 times 96 minus 21 over 28, and that is plus 9 over 28, and 16 times 75 over 28 plus 9 over 28 is 16 times 75 plus 9 is 1209 over 28. All right, that's it for this video, and we'll come back next time and we will talk about suggested homework problems from 5.1. See you for the next video.